All right, guys. So, like I said, this is going to be kind of like adding and subtracting just regular fractions. Okay. So, I'm going to start you off today with a couple examples of just working through some regular fraction addition. Make sure we're solid on that stuff, and then we'll get into the rational expression version of it. So let's say we would like to add together 3/4 and 1/8. So, somebody tell me, what should we do first to get this thing started? Yeah.
So you should get 3/4, so it's in 8, so you times it by whatever's on the it's hard to explain.
Multiply the 3/4 by 2.
Sorry, Logan.
Okay, so you want to turn the 3/4 into something over 8 so that they match. Is that what I'm hearing? Okay, and then I heard over here, multiply by 2. Okay, because you can multiply 4 by 2 to get 8, and so then we've got 6/8 instead of 3/4. Okay, somebody else. Now what? Okay, and you add just the numerators, and the denominator stays the same. Okay, so it's kind of like you have 6/8 and you have 1/8. So how many eighths do you have altogether? You have 7/8, right? Think of it like that. Kind of like you were doing, like adding, like in second grade or whatever, you have 6 apples and 4 apples, and you have 10 apples, kind of a thing. It's an easy way to think about fractions. I mean, don't. All right, so let's try another one. How about 3/13 minus, we'll do subtraction this time, 2/7. Ooh.
I remember that. You trying to play the little trickery. It's not going to work.
What's different about this one from the last one that makes this one a lot harder?
Do it by 2. Oh, I got it. 7 does not go to 3.
Yeah, there is not, one of them is not a factor of the other one, right? In the first one, we were able to do it pretty easily because 4 is a factor of 8. So you just multiply 4 by 2 and boom, they match. Now I got to change both of them though. And that was really mean, and I gave you a 13 in there too. So how do we get that common denominator this time?
You multiply across the bottom.
Mm-hmm.
And then you cross multiply.
We don't cross multiply, actually.
No?
Well, unless you're saying cross multiplying but meaning something else, I don't know. But okay, so what is the common denominator here though?
91.
It's 91? Okay. All right, and you got 91 by doing what? 13 times 7, okay. And so if the first one was 3/13, then how am I going to figure out what the new numerator needs to be then? 3 times 7, because we multiplied that denominator by 7, so we'd have to also multiply the numerator by that. So we've got what then? 21 91/91. And then what about the other one then? 26. So it's 21/91 minus 26/91. How many 91sts do we have? There you go. Yep. Same deal though. You do the subtraction up top. Leave the denominator the same. -5/91. Got it. That's not technically cross multiplying.
You do a cross and then you multiply it through.
Technically, cross multiplying would be like if you had 2/3 equals x over 6, and then you do 3 times x is 3x, 2 times 6 is 12. That's cross multiplying. But I see what you're saying though, because you did do 13 times 2, and you did do 3 times 7 technically to get those numerators. But technically, this is cross multiplying. But yeah, but I hear you at the same time. Yeah. As long as you can do the process, you're fine. Okay, so let's pull this into some rational expressions then. See if we can apply the same kind of rules we just talked about here, doing it with some rational expressions instead. So let's say I want to add 1 over x plus x over x plus 2. Now, the common mistake that's made with this one is, oh, I know what that common denominator is. It's x plus 2. Because this one's got an x in it, this one's got an x and a 2, so it's just got to be x plus 2, right? You got it. You have to multiply things together to make your like terms, kind of like we did up here, right? When we made these 91s, how did we get those 91s? 13 times 7, not 13 plus 7. We had to multiply things together to get those, okay? So be careful you don't fall into that trap. Because just because you see an x in both of them doesn't mean that that's okay, and then all you got to do is put the plus 2 on it. You have to actually multiply things. So in rewriting this thing with common denominators, it's going to be x times x plus 2 on both of them. And you can write it like this, that's fine. If you want to distribute and all that business, that's fine. But for now, we can leave it like this. This, I think, actually helps you, too, to visualize what you need to multiply the top of each of those with. Okay? So if I've got x times x plus 2, what am I going to multiply times the 1 then? X plus 2, right? Because that's what got multiplied onto that denominator. We had an x. Now it's x times x plus 2. Whatever you multiply down here, you have to multiply up here as well, right? So it's 1 times x plus 2, or just x plus 2. Okay, and then what about the other one? Well, it's x times x plus 2. It used to just be x plus 2, so what needs to get multiplied up here? Another x, right? So it's x squared. It's not 2x. Careful with that, too. Okay, so that's where we're at. X plus 2 over x times x plus 2 plus x squared over x times x plus 2. And then just like before with the fractions, go ahead and add the numerators and leave the denominator the same, right? So we still got this x times x plus 2. And then add the numerators together. But if there are no like terms, then you just put it all together with the plus signs in the middle, right? So that numerator for this one would be x squared plus x plus 2. If I kind of wrote that in descending order there. Okay. So all of that added together over x times x plus 2. And to finish it off, go ahead and multiply that out then. So our final answer is x squared plus x plus 2 over x squared plus 2x.
Doesn't that all cancel out though?
Nope. It doesn't. Not unless you can factor the numerator and cancel it with a factor in the denominator. But remember, like we talked about yesterday, you can't cancel these. That x squared does not cancel that x squared, because you can only cancel factors with factors. X squared is not a factor, it's a term. Cannot cancel terms, you can only cancel factors. So that's done. Like I said, unless you can factor the top and factor the bottom and find something that cancels that goes into both of them. But in this case, you're not going to be able to do that because the top polynomial there doesn't factor. So it's done, just like that. The other thing they're going to be asking you guys to do with these is to state the domain. Okay. And the only reason they do that is if you have some sort of an expression where there's fractions involved, when x shows up in a denominator, there are going to be certain numbers for x that you can't plug in then, right? So looking at the way this problem was set up, you don't even need to look at the answer. Just look at the original problem. What numbers for x immediately jump out at you that are not going to work? 1 is fine. 0 and -2. Yeah, those are going to be the ones that don't work. So to write domains for these, you can just do it like this. X not equal to 0 and -2, and that's fine. Okay? Because if you put a 0 in this first fraction right there, bad news. All right, let's try one more of these together, and then I'm going to have you guys jump into your journals and do a little bit of work out of there, practicing what we're talking about here. I know. All right, so this one, we've got x plus 1 over x minus 3 plus x minus 2 over x squared minus 5x plus 6. Oh, this should be x plus 2, not minus 2. Okay, so before you jump into trying to get a common denominator here right now, don't multiply those two denominators together. Yes. So here's the thing. If you have one of those two denominators that you can factor, you might end up with something that's a little bit more useful into trying to determine what that common denominator is going to be. So that's what we're going to do first here, is just factor out that second one, because that will factor. And what does that factor to? X squared minus 5x plus 6.
X minus 3 times x minus 2.
Yeah. So looking at that now, what is the common denominator? X minus 3 times x minus 2. Okay, so that x minus 3 from the first one is good to go because it shows up here too as a factor, right, as something multiplied with it. So then what do we need to do to get a common denominator for this then?
Well, why don't you just cross out x minus 3 on the bottom?
Because they don't cancel like that. You only cancel if it's in a numerator and a denominator together. But I think I heard it over here. This already has an x minus 3, so if we just multiply this with another x minus 2, and then just make sure we do the same thing to the top, right, then we'll have the same denominator there. We're good to go. This thing, we don't even need to change. It's already got the common denominator we want. This one is kind of like the very first fraction problem we did, right? One of them already had an 8. I could get the other one to be an 8 as well, so I didn't need to change the second fraction. On this one, that second rational expression has already got the denominator that I want, so I don't need to mess with that one anymore. I can just leave it like it is. And so this first one, though, so I've got x minus 3 times x minus 2 is my common denominator, so I'll leave that there. And then this one I can just copy down. So what needs to go on the top of that first fraction then? We need to have an x minus 2 multiplied with the x plus 1, right? Kind of like that. And before we can add these things up, though, because remember, when we added these, like the last ones, we were looking for like terms and that sort of thing and adding them all together. You got to FOIL this thing out. The denominators we can leave alone for right now. We don't need to multiply those out. But this needs to be FOILed out so we can see what like terms we have when we actually go through and add everything up. So that's going to be the next step that we got to do. So that would be x squared, minus x minus 2 looks like. Okay, and now we're ready to actually go through and add everything up. Okay, so x squared minus x minus 2 plus x plus 2. What do you notice there? If we were to add those numerators. Right. Yeah, the negative x cancels with the x, the negative 2 cancels with the 2. We're just going to have x squared when we're done. So we've got x squared on top over x minus 3 times x minus 2. And now, to finish it up, you can go ahead and multiply that denominator back together, because there's nothing down here that's going to cancel with x squared, right? Remember, only a factor can cancel a factor. So the only way for these two to be canceled off would be to have that factor somewhere in the top, and it's not there. It's just an x squared. So x squared over x squared minus 5x plus 6. And then let's go ahead and do the domain for this one too then. Remember, look at the original problem. What numbers are going to be bad? 2 and 3. Yeah, x not equal to 2 and 3 would be the domain then. All right, so we're going to take a little time, going to transition here, let you guys work on some stuff out of your journals here. I should turn to page 205. Later, we got some good practice in yesterday, but I want to make sure. We actually did do that a little bit in some of the previous sections. That was on your quiz, if you remember, too. There was one question where you had to do this and then write it that way. This whole idea. Complex fractions, which basically means a fraction in a fraction. So we're going to have some problems. Some of you guys were looking yesterday like, oh, we're going to do these. Yeah, it's like a little fraction in a bar and then another little fraction. Like, b plus 2x over x minus 2, 3 minutes. I'm going to freeze it up here. You guys try it on your own. If we end up in the same place or not. Also, like yesterday, I'd like you to also determine what is the domain of that particular expression. Take shortcuts. Write it all out. Okay? It will tend to go better. You guys need a little more time? What, 8? Oh, that's a 9, yeah. If it was an 8, that would make it pretty complicated, but yeah, it's just a 9. It's a number. All right. Any more time? All right, let's. One together. We're doing your common denominator, and then you're multiplying by the correct things on the top as well. Then adding those together, combining your like terms in the next step after. Together. I was looking in your textbook a little closer. It looks not equal to 3 and negative 1. So, does this all make sense?
Yeah.
Okay. Test quiz type stuff. This is going to be the difficulty we're looking at for the most one today. You're fine. this thing been moved up or down, left or right? Because of the h and the k, those tell us those things, right? In a transformation, how far left or right it went, tell us how far up. 3x 2. Now, I do that. Well, out. One, right? In what direction? Up 3. Have to make it. Make a little synthetic division, and that if that made sense and you were totally fine with that, boy, it's fine. I don't. Is it easier? Want to do some that are just regular fractions, not these rational expression things. So just using numbers rather than x and all that business. Technique down. Fraction. 4/5. Okay, in the mix there too. So step, something like that. Okay, good. So we've got that addition of two fractions on the top, right? We know how to add denominator stuff. So let's take care of that and kind of see where of those two fractions on the top. Sixths. 4/6. For work with you guys, that sort of thing. You generally don't want those. The reason they do those with you is so that you can have a kind of a sense of how big your answer is. You know, like 6 and 1 or 1 and 1/6, you can kind of visualize that a little better than 7/6. But when you're most of this, right. Now we're back to what we did, like division problem. That addition on the top into one fraction, I can just divide like I've always done. But kind of look to it as the last one. I just put the addition on the bottom now instead of the top, but the addition or subtraction piece of it first, then do your division. Denominator for this.
X squared plus 4.
x times x plus 4 instead of actually multiplying those together. There's nothing wrong with that either. Three x plus. Go on. Change it, flip it if you like that. Just the denominator. Reciprocal of that. Or you just start blindly together that'll factor here yet. And if we have things that'll factor, and then we can find some things that cancel, we're going to want to do that. Okay? That second fraction factors, right? Because you multiply that together to make it, right? That's why I said you might not want to actually multiply those together, but if you do, it's not going to hurt anything unless you miss it here. Why? Feel like these complex fractions, for the most part, it's going to be a situation. Like I did here. Fine. People that try to take shortcuts because they don't want to write so much are going to make mistakes. It happens every single time. That